So this is the IGCSE higher paper from the 21st of May 2019. And at the bottom there you can see I've got the grade boundaries for this paper, and that 5 just cross-references it into my filing system on YouTube. So question 1. Now you've got to be very careful with these show that questions, that you absolutely indicate every single step. Okay, so always start off with the left hand side, do the workings for that, and finish off with the right hand side. So left hand side. So first of all, I'm converting these two mixed numbers into top heavy fractions. So 4 2/3 is 14/3, and 1 1/9 is 10/9. Now, how do you do a division of fractions? Well, you keep the first fraction the same, you change it from being a division to a multiplication, and you flip the second fraction over. So 10/9 becomes 9/10. Now, you could at this point just do top times top, bottom times bottom. You could do 14 times 9 and 3 times 10 and simplify from there. But I've just taken the opportunity to cancel down in advance. So the 14 and the 10 can both be divided by 2, and the 9 and the 3 can both be divided by 3, leaving me with 7 3s are 21 and 1 5 is 5. So 21/5, and that, changing that into a mixed number, is 4 1/5. Question 2. So for part A, now this is only worth 1 mark, so you don't really want to spend time working out numbers for this. So all they're looking for is the fact that if you compare the first journey from 10 o'clock to 11 o'clock, that part of the journey, to the second part of the journey on our way to the park, you can see that the slope is steeper on the first bit of the journey. So that's all they're looking for. So Julina cycled faster before stopping at a friend's, because this is when the slope is greater. Now for part B, we've got to show all the information on the distance time graph. So she stayed at the park for 45 minutes. Now looking at the scale here, you can see that it's 1, 2, 3, 4 squares for an hour. So each square represents 15 minutes. So she stays at the park for 45 minutes. That's why we've got 3 squares at the top. Now, she travelled home at 16 kilometres per hour. So she goes 16 kilometres in 60 minutes. Now, the journey home, we can see that she's 24 kilometres away when she's at the park. The scale on the y-axis, we're just going up in ones, 21, 22, 23, 24, 25. So she's got to travel 24 kilometres to get home. Now, if she goes 16 kilometres in 60 minutes, 24 kilometres, well, that's just 1.5 lots of it, is going to take 90 minutes. Now, given she leaves the park at 12:45, because that's 3 squares along there, 90 minutes later is 2:15, so she gets home at 2:15, so that's just 1 square along from 2 o'clock. So just drawing a straight line there. Now, for part C, we've got to work out the average cycling speed, but do not include the times when she's not cycling. So the total distance travelled was 24 kilometres to the park, 24 kilometres back, so that's 48 kilometres. And how long was the total time? Well, the first part of her journey before her rest was exactly an hour. Then the second part of her journey here is 3 squares worth, so that's 45 minutes. And we've just said it took her 90 minutes to get home. So 60 minutes plus 45 minutes plus 90 minutes is 195 minutes, which is 3 1/4 hours. So speed is distance over time, so that's 48 divided by 3.25, which is 14.76 recurring, which is 14.8 to 1 decimal place. Question 3. So index laws, when we divide, we subtract the powers. 9 take away 5 is 4. Now, when we have a power inside the bracket and outside the bracket, you multiply these together. 2 8s is 16. Now, expand means get rid of the brackets. Simplify means gather like terms. So do your for clause, and then make sure you multiply. So x times x is x squared. X times minus 2 is minus 2x. Plus 9 times x is plus 9x. And plus 9 times minus 2 is minus 18. So that's 1 mark. That's expanding. Then gather your like terms. So gather up their x's in the middle. Minus 2x plus 9x is plus 7x. Part D, factorise fully. Now, fully is telling you that you're going to be taking more than one component outside the bracket. So just work your way along. What's the highest common factor of 16 and 20? It's 4. What's the highest common factor of c to the power of 4 and c? It's c. What's the highest common factor of p squared and p cubed? It's p squared. So all of that comes out of the brackets. Then open your bracket and think of that first clause. 4cp squared times what would give us 16c to the 4p squared? Well, we need a 4, because 4 4s are 16. We need a c cubed, because c times c cubed is c to the power of 4. And we don't need any more p's. We've already got our p squared. Then get your sign right. It's a plus question. Then how do we get the 20? Well, that's 4 times 5. We've already got the c in place. Then how do we get a p cubed with a p squared outside the bracket? We just need a p. So that is our final answer for part D. Question 4. So this is a quadratic graph we're going to be plotting, and given that it's a positive x squared, it's going to be a positive parabola, it's going to be a smiley face graph. Now, to help you fill in the table, look out for the symmetry. Okay, so and you're really only going to start spotting that when you start filling in, when you get the same y value cropping up more than once. Now, to start with, we don't have any symmetry because we've just got a -1, a -3 and a 3. So if I were you, start off working out some of the positive values. That's a lot easier than doing the negatives. So when x is +1, substitute that into the formula. So y equals 1 squared, take away 3 lots of 1, take away 1, which is -3. So when x is 1, y is -3, and I filled that in. Now I've got some symmetry. Look, I've got the -3 and the -3. So just to think of that as a ripple in the pond. Okay, just pop in that little arc there. So -3 matches with -3. That means that -1 is going to match with a -1. So that's bound to be -1. Similarly, that 3 matches with that 3 over there. So I haven't needed to work out that those two values. I can just rely on this symmetry. That does mean I've got to work out this value over here. So when x is -2, now be very careful to protect the minus here. -2 squared on your calculator will give you -4, which is wrong. You need to put the -2 in a bracket. So you need to put exactly that into your calculator. -2 squared in a bracket, -3 lots of -2 in a bracket, -1 gives us +9. Now, if you're not confident with this symmetry business, of course, you can just work out these y values just substituting in, but just be careful to protect the minus. Now, plotting the graph, we get a nice gentle curve. Do not join these points of straight lines. You will lose a mark. Do not give it a flat bottom. It must be curved at the bottom. Question 5. So we know the probabilities must add up to 1. So that's our starting point for working out x. We've got to construct an equation. So adding up the x's, we've got a 2x plus a 2x plus a 3x plus an x, which is 8x. Then adding 0.18 to 0.26, we get 0.44. And these together have to add up to 1. So that's us constructing an equation which we then solve. Take away 0.44 from both sides, then divide by 8, we get x being 0.07. So we can then work out what 2x, 2x, 3x and x are, because it's 0.07 is what x is. Now the probability of an even number is obviously a 2, 4 or a 6 added together. So that's 0.18. Add 3 lots of 0.07, which is 0.21. And then for a 6, add up 1 lot of 0.07, which together, so the probability of a 2, a 4 and a 6 adds up to 0.46. So the probability of an even number is 0.46. So if Becky's going to throw the dice 200 times, how many even numbers would she expect to get? 200 lots of 0.46, which is 92. Question 6. So we're being asked to work out the mass of the cuboid. Now, density equals mass over volume. Rearranging this by multiplying both sides by volume, we get mass equals density times volume. And we're told that the density is 0.7. So we just need to work out the volume. Now, the volume of a cuboid is just the area of the cross-section, which is 8 12s and 96, times by the depth of the prism, which is 5, which is 480. So the mass is the density of 0.7. times the volume of 480, which was 336. This was as straightforward as that. You didn't have to fiddle with any of the units. The density was given in grams per centimetres cubed. The lengths were in centimetres, and your final answer had to be in grams. So there was no need to change any units. Question 7. So write 5.7 times 10 to the 6 as an ordinary number. So it may well be that you can just plug this into your calculator and it will give it to you. But going old school, just sort of working it out, because it's times 10 to the 6, it's a positive power, it's going to be a big number. So just pop in lots of noughts after it, just as part of your working, and then just hop the decimal point 6 places. So 1, 2, 3, 4, 5, 6. The decimal point ends up here. So we can see we've got 5 zeros after the 7. Now, and similarly for part B, to write this in standard form, well, in standard form, the first number is always between 1 and 10. So where would you put a decimal point to get this number between 1 and 10? Well, it would be after the 4. So it's 4 times 10 to the something. Now, because this is a very small number, the power will be minus. And again, to work out the power, we've just got to consider the number of hops. How many hops does the decimal point go from where it starts to where it needs to finish, which is after the 4, to give us 4. So that's 1, 2, 3 hops. So that's 4 times 10 to the minus 3. Now, for part C, please just use the fractions button, which is the third one down on your calculator, looking like this. And I think just to be on the safe side, perhaps, just pop them into brackets. But no, your calculators should be fine anyway. But just better safe than sorry, perhaps just put them in brackets. Okay, so pop that as the numerator. Use the arrow key to go down to the denominator. And that gives us 5 million. Now, the question doesn't ask us whether he wants the answer as a normal number or standard form. So just leaving it as a normal number is absolutely fine. Question 8. So, the boat is depreciating by 8% per year. So it's going down in value by 8% per year. So we start off with 100%, we take away 8%, giving us 92. So how do we convert 100 into 92? 92 divided by 100. We've got a multiplier of 0.92. So each year you can work out the value at the end of that year by multiplying the value at the beginning of the year by 0.92. So this goes on for how many years? Well, from the 1st of January to 2016 to the 1st of January 2019, that's 3 years. So every single year, the value that remains at the end of each year is 0.92, what you started with. So over 3 years, the value is going to be 0.92 to the power of 3. So it's quite simple, these. You take the initial cost of the boat, 170,000, multiply that by the multiplier 0.92 to the power of the number of years, which is 3, giving us this. So to the nearest dollar, that's 132,377. Question 9. So this is a compound shape, so just break it down into the semicircle and the triangle, and we're going to work out the area of each and add them together. So the area of the triangle, well, that's just going to be half times base times height. Here's the triangle just rewritten. So that's going to be half times 6 times 6, which is 18. So that's our first area. Now, for the semicircle, we're going to need the radius, which is obviously halfway along A to C. So I'm going to call that A to O. Okay, now we need to know the diameter. We need to know A to C, and then we can halve it to get the radius. So how do we work out A to C? Well, think back to the right angled triangle. A to C is the hypotenuse of the triangle where the two shorter lengths are 6 and 6. So we can work out the length from A to C just by using Pythagoras. So AC squared equals 6 squared plus 6 squared, which is 72. So AC is the square root of 72. So our radius, A to O, is half the square root of 72. Now, the area of a semicircle is half the area of a circle. Now, the area of a circle would be pi r squared. So the area of half a circle, the semicircle, is half pi r squared. So that's half times pi times our radius of half of root 72 squared. Popping all of that into your calculator, we get 9 pi. So that is our second area. So to work out the combined area, we take the area of the triangle, which is 18, add that to the area of the semicircle 9 pi, press your SD button to turn that into a decimal, and we get 46.274 dot dot dot. So to one decimal place, that's 46.3. Question 10. So a is 2 to the power of n times 3 times 5 to the power of m. Now 8 lots of this is obviously just going to be 8 lots of a. So that's going to be 8 lots of our 2 to the n times 3 times 5 to the power of m. Now what is 8? 8 is 2 cubed. So we've got 2 cubed times 2 to the power of n times 3 times 5 to the m. Now think about the 2 cubed times 2 to the n, where we've got the same base number, the 2. When we're multiplying, we add the powers. So that's going to be 3 add n, or n add 3. So this is going to be 2 to the power of n plus 3, which is these two times together, multiplied by 3, multiplied by 5 to the power of n. Question 11. So let's start off by just working out the lower bound and the upper bounds of a and b. So 6, it rounds to 6 correct to the nearest whole number. So the lowest it could be is 5.5, and the highest it could be is 6.5. Remember the symmetry here, that's 0.5 away from 6, so we make the upper bound also 0.5 away from 6. Now for part B, it's 15 correct to the nearest 5. So the lower bound there is going to be 15 take away half of 5, which is 12.5, and the upper bound will be 17.5. Now we want to work out the upper bound for C. Now when you're taking away, how do we maximize this? We want B to be as big as possible and A to be as small as possible. So we want the upper bound for B take away the lower bound for A. So that's 17.5 take away 5.5, which is 12. Question 12. So for the first part, we're factorizing this. Now, because we've got a 2 in front of the x squared, it may be that you can just do this by inspection, that you just trial and error and go straight to answer. I can't do that. I have to use this more long-winded method. So my two magic numbers multiply to be the 2 times 6, which is 12, but add to be the minus 7, the coefficient of x, which is minus 7. So which two numbers multiply to be 12 but add to be minus 7? That's minus 3 and minus 4. Now we can't go straight to answers with this. What we've got to do as the first step is to split this from being 3 terms to 4 terms. So the 2x squared and the plus 6 remain as they were, but we split the minus 7x down to minus 3x and minus 4x. Doesn't matter which way round you write these down. So I've written it minus 4x and minus 3x. You then, firstly, you fully factorize the first two terms. So you fully factorize 2x squared minus 4x, which is 2x bracket x minus 2 close bracket. And then you fully factorize terms 3 and 4, and you will see that you get this repeated bracket. Now your final answer is then the first bracket comprises the two components that aren't in a bracket. So that's the 2x minus 3, and the second bracket is the repeated bracket of x minus 2. Now, for part B, we need to start off by undoing this division by 3. So start off by multiplying both sides by 3. So we get 4m plus 9 equaling 3 lots of 7 minus 2m. So then do the claw on the right-hand side, 3 times 7, 3 times minus 2m, giving us 21 minus 6m. If we then add 6m to both sides, and take away 9 from both sides, we get 10m equaling 12. Then divide by 10, we get m being 12 over 10, or 1.2, or its equivalent. Now for part C, the fourth root of y is y to the power of a quarter. And then we're dividing this by y, so we're obviously dividing by y to the power of 1. Now, when you divide, you subtract the powers. A quarter take away 1 is minus 3/4. Question 13. So, Group C, there are 6 girls and 8 boys, so that's 14 in total. So the probability of picking a girl from this group is 6 out of 14, and a boy is 8 out of 14. Now, Group D, 3 girls, 7 boys. The probability of a girl is 3 out of 10, and a boy is 7 out of 10. So 3 out of 10, 7 out of 10, 3 out of 10, 7 out of 10. So that's completing the probability tree. Now, for part B, work out the probability there are 2 boys in the team. So it's a boy from group C and then a boy from group D. Now, when it's an and, you multiply them together. So 8 over 14 times 7 out of 10, which is 56 over 140. Now, that's fine as a final answer, but you could have simplified it down to any of these. Now, for part C, one child is picked at random from the children left in group C, and one child is picked at random from the children left in group D. Work out the probability that there are 2 boys in each of the 2 teams. Okay, so we need a boy to be from team 1 and a boy from team 2. So we're going to be multiplying these 2 together. Now, we know the probability from team 1 of 2 boys is 56 over 140. Now, given that we've gone and picked a boy from Group C and Group D for Team 1, when we go back for Team 2, to probability of then picking a boy from Group C, well, a boy's already gone, isn't it? We've already lost a boy to Team 1. So there's now going to be 7 boys left out of a possible 13 children. Okay, so that there, 7 out of 13, is the probability that Team 2 has a boy from Group C. Now, similarly, what's the chances of picking a boy for Team 2 from Group D, bearing in mind that a boy has already been picked for Team 1? So rather than being 7 out of 10, given a boy's gone, it's going to be 6 out of 9. So 6 out of 9 is the probability that Team 2 has a boy from Group D. So the probability of 2 boys in Team 2 is 7 out of 13 times 6 over 9. So multiply these 3 together, you get this, which simplifies down to 28 over 195. Question 14. So I think the easiest thing is to create a Venn diagram here. So we've got A and B as the 2 rugby balls. Our universal set, so everything that's going to go somewhere inside the rectangle are the numbers 1 to 20. Now in rugby ball A, we need all the numbers that are less than 12. But bearing in mind, in B, B's got to include all the ones greater than or equal to 7. So in A only, we're going to have 1, 2, 3, 4, 5, 6. In the overlap between A and B, we're going to have 7, 8, 9, 10, and 11. Because they should be in A because they're less than 12, and they should be in B because they are greater than or equal to 7. Now, then moving on to B, we've got everything now that's in A, so that rugby ball for A is complete. Now for B, we've also got to include the numbers that are less than 16. So the 12, 13, 14, 15 go here, leaving 16, 17, 18 and 19 on the outside. So list the members of A intersection B. That means the numbers that are in A and in B. So it's the overlap here in the middle. That's 7, 8, 9, 10 and 11. Now for part B, we've got to understand this notation here. This bit here means that C is an element of A. C is in A. So C is going to be within 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or 11. Okay, so C is going to be from those. Now we're told that the number of numbers in C are 3. Okay, so we're going to be picking 3 numbers. Okay, and then we're told that all members of C are even numbers. So we've got to pick any 3 of these which are even. So that's picking any 3 of 2, 4, 6, 8 and 10. So any 3 of these would do. For example, 2, 4 and 6. Question 15. So let x equal 0.254 with the 2 dots. So that's 0.25454545 dot dot dot. Now, because they're 2 dots, multiplied by 100. So 100x equals 25.454545. And because we've multiplied by 100, you'll see that once we get to the 100th column and onwards, our numbers line up. So if we call this equation 1 and we call this equation 2, let's do 2 take away 1. So 100x take away x is 99x. and 25.454545 take away 0.254545 is 25.2. Now at this point you could in theory divide by 99, but I think it's clumsy to have a fraction as part of a decimal as part of a fraction. So I would prefer at this point that you choose to multiply by 10. So we get 990x equals 252 and then divide by 990. So x equals 252 over 990, which simplifies down to 14 over 55 as required. Question 16. So here we're just going to be using the formula that's given at the front of the paper, the sum to n terms of an arithmetic series. Now a is the first term, which is 7. D is the common difference, that's how much we're going up by each time, which is 3. And we're summing the first 100 terms, so n equals 100. So just simply substituting these three numbers into the formula, we get this top line. Obviously 2 times 7 is 14, 100 take away 1 is 99, 99 times 3 is 297, and 14 add 297 is 311, 50 lots of 311, 15,550. Question 17. So we're told the height of vase A is 24 and vase B is 36. So proportionally, if we divide these by 12, the ratio of the heights is 2 to 3. So our length ratio is 2 to 3. Now for part A, we're talking about the surface area. Now, if the length ratio is 2 to 3, the area ratio, area being two-dimensional, is the length ratio squared. So that's 2 squared to 3 squared, which is 4 to 9. Now, we're told the vase A has a surface area of 960, so that represents the 4. So what's going to be the area of B? Well, take your 960, divide that by 4 to get back to one part, which is 240, multiply that by 9, we get 2160. Now, for part B, we're talking about volume. Now, if the length ratio is 2 to 3, the volume ratio is 2 cubed to 3 cubed. Volume being three-dimensional, you cube the length ratio. So the volume ratio is 8 to 27. So if the volume of B is V, the volume of A is going to be 8/27 of V, or in other words, 8V over 27. Question 18. So, where we've got a side angle side like this, we're going to use the cosine rule, which is given at the front of the paper. Now, the capital letter represents the angle, so I think it's always easier to adjust the lettering to reflect how the cosine rule is given. So the angle is obviously the 36, so I'm calling that capital A. So the side opposite would be lowercase a. Doesn't matter which way around we make B and C. So we then just simply substitute into the formula. So B is 17.8, C is 26.3, and capital A is 36. So substituting in, I've done there on that first line. Popping all of that into my calculator, I get 251.063 ... Square root to get A, I get 15.844 ... So to three significant figures, remember that just means 3 digits in total, that's 15.8. Question 19. Now, I think people always overcomplicate histograms. It really is quite straightforward as long as you realise that frequency represents the area of each bar. So first thing to do, just write area over frequency. So that's got to be the area of each bar. Now, the base of each bar for this question, the base of each bar is going to be the height. Okay, so the width of each bar is going to be these lengths here. So going from 0 to 20, which is a width of 20, 20 to 35, which is 15, 35 to 40, which is 5, and 40 to 50, which is 10. So that's the width of each bar. Now that's the area of each bar. So how are we going to work out the height of each bar? Well, how do you work out the area of a rectangle? It's just base times height equals area. So here it's just going to be the other way around. It's going to be area divided by the width of each bar, which gives us the height of the bar. So I've done 15 divided by 20, 48 divided by 15, 21 divided by 5, 16 divided by 10 to give me these heights. Then I simply just fill in those bars. So my first bar has a width of 20, a height of 0.75, width of 20, height of 0.75, and so on. Base of 15, height of 3.2, base of 5, height of 4.2, and a base of 10, height of 1.6. Question 20. Now, I thought this was quite tricky. The way to sort of enter this question, to get into this question, is to appreciate you need to put in the line from B to D. All right, so put in the line from B to D. Then it's only really the next step, which is quite tricky. You've then got to realise that angle A to B to D is 71 from the alternate segment theorem. So that's your first line of workings. The angle ABD is 71 because of the alternate segment theorem. From then onwards, it's quite straightforward, I think. Because we've got these little dashes here, ABD is an isosceles triangle. So because we know this blue angle is 71, the red angle must be 71. Reason being, base angles of an isosceles triangle are equal. Obviously, once we know the red angle and the blue angle, the purple angle is just going to be 38 because our angle's in a triangle. So angle BAD is 38 degrees, angles in a triangle total 180. And once you've got the purple angle, the angle that we want, BCD, is going to be 142 because opposite angles in a cyclic quadrilateral total 180. So just make sure, because it says give a reason for each stage of your workings, that you've written a sentence down for each of those four angles. Okay, just like I've done there. Question 21. So we're told that the ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. So let's go and call the radius of the cylinder r. So the height of the cylinder, which is 3 times as big, we can call 3r. And then obviously the radius of the hemisphere will also be r. So those are all our measurements. Now, we've got the appropriate formulae at the front of the formula booklet. So our volume is going to comprise the volume of the cylinder, which is going to be pi r squared times the height, which is 3r. So that's pi r squared times 3r. And the volume of our hemisphere, well, the volume of a whole sphere is 4/3 pi r cubed. So the volume of half a sphere will be half of this, which is 2/3 pi r cubed. Now we know when we add these two volumes together, we get a total volume, which we're told is 792 pi. So we've constructed our equation. The volume of the cylinder plus the volume of the hemisphere equals the total volume. So just multiplying out the first term, I get 3 pi r cubed. And then I can gather together my pi r cubes. I've got 3 lots of pi r cubed at 2/3 pi r cubed is 3 and 2/3 pi r cubed. I've then cancelled my pi's, divided through by pi, and then dividing through by 3 and 2/3, I get r cubed being 216. So if that's r cubed, the cube root of this gives me a radius of 6. So the total height of the solid is going to be this height here, which is 3r, plus this height here, which is another r, is going to be 4r. So the total height of the solid is be 4 lots of 6, which is 24. Question 22. So anything inside the brackets affects the x-coordinate opposite to what you would expect. So we're going to take away 30 degrees from each x-coordinate. Then anything outside the function affects the y value as you would expect. So that's doubling the y-coordinate. Okay, so just repeat that. Anything inside the function affects the x value opposite to what you would expect. Anything outside the function affects the y-coordinate as you would expect. So we're just comparing it to the normal sin curve, which they've given us here. So really for each coordinate, you just need to take away 30 from the x-coordinate and double the y-coordinate. So I've just done a variety of coordinates over here. Okay, so where I'm just taking away 30 from the, so that's my original point. Then I'm just taking away 30 from the x-coordinate and doubling the y-coordinate. So my curve looks like this. Now, completing the square for B part 1. Remember where we start off. You halve the coefficient of the x. So we halve the -6 to get -3. So that's where the minus 3 came from. Now picture multiplying out the bracket x minus 3 times x minus 3. You get x squared minus 3x minus 3x plus 9. So that's x squared minus 6x plus 9. But we don't want that plus 9. So we back out that plus 9 with a minus 9. So x minus 3 all squared minus 9 is exactly the same as x squared minus 6x. And then, of course, we've got the plus 10. Then simplify, minus 9, add 10 equals 1. So that is writing it down in the form they required. Now, this then leads into part 2. It's a hence, isn't it? So if you just imagine you've got y equals x squared compared to y equals x minus 3 all squared plus 1, it's the same point. Inside the function affects the x value opposite to what you would expect. So we're not going to be taking away 3 from the x value. We're going to be adding 3 to the x coordinates. Outside the function, the plus 1 affects the y coordinate as you would expect. So we're going to be adding 3 to the x coordinate and adding 1 to the y coordinate. So it's a translation by the vector 3, 1. Question 23. So I've done a sketch here. I think you really do need a sketch to help you gather your thoughts. Okay, so AB is the same length as AD, and BC is the same length as DC. And I've just made sure I've got my coordinates sort of broadly right. So D is the coordinate 2, 7, B is 10, 19. So B's obviously got to be up to the right and above D. Now, in order for us to work out the equation AC, we're going to need to know two things. We're going to need to know a point on the line. Now, one of the properties of a kite is that the halfway point of BD will be on the line from A to C. So we can work out a point on the line AC, which I'm going to call E, by working out the midpoint of BD. So we'll do that in a minute. So that will give me a point on the line AC. Then secondly, I'm going to need to know the gradient of the line AC. Now AC is going to be perpendicular to the line BD, another property of a kite. So if I work out the gradient of BD, I can then flip it over and change the sign to work out the gradient of AC. So that's the plan. So how do I work out the midpoint of BD? Well, you average the x coordinates and you average the y coordinates. So I've averaged 10 plus 2 and I've averaged 19 plus 7 to give me, so 10 plus 2 over halved and 19 plus 7 halved gives me 6, 13. So that's the midpoint. That's the point I'm calling E. Now the gradient of BD is the y step, the height of that triangle, the y step going from 7 to 19, which is a height of 12, divided by the x step going from 2 to 10, which is 8. So the gradient of BD is 12 over 8, which simplifies to 3 over 2. So my gradient of AC, my perpendicular line, flip it over and change the sign, gives me minus 2 over 3. So I've now got a point on the line and I've got the gradient. So substituting that into the y minus y1 formula, I get y minus 13 equals minus 2/3 x minus 6. Now, I'm given that how they want the final answer in sort of integer format, I'm taking the opportunity here to choose to multiply both sides by plus 3. So 3y minus 39 equals minus 2 lots of x minus 6. Now, minus 2 times x is minus 2x. Minus 2 times minus 6 is plus 12. I've then added 2x to both sides, added 39 to both sides to get 3y plus 2x equals 51, which is the format they wanted the answer in. Okay, so question 24. Now we're being asked to find the value of t for which the acceleration of p is 3 meters per second squared. So we need a formula for acceleration. Now, when you differentiate displacement, you get velocity, and when you differentiate velocity, you get acceleration. So we're going to have to differentiate this twice. So first of all, differentiate for the first time. So remember how you differentiate. Step 1, you multiply by the current power. Step 2, you reduce the power by 1, and you go term by term by term. So t cubed becomes 3t squared, minus 6t squared becomes minus 12t, and plus 5t becomes plus 5. and the minus 4 falls away. So that's the velocity. That's the different when we've differentiated displacement. And then secondly, we differentiate this again to get our acceleration. So 3t squared becomes 6t, and minus 12t becomes minus 12. So 6t minus 12 is our acceleration equation. Now we're told the acceleration is 3, so 3 equals 6t minus 12, so we just need to solve this. So add 12 to both sides, divide by 6, and we get t being 2.5 seconds.